In the last video, we saw different types of errors and exceptions that can occur when we code in Python. In short, Python has many built-in exceptions and they're raised when your program encounters some form of error. So what will happen is, when these exceptions occur, the Python interpreter will actually stop running the current process and will check to see if it is handled. If it's not handled, then the program will just crash on you. In this video, we're going to explore how we can handle exceptions. And in Python, the way we do this is by using what is known as a try statement. So here we have the same function as we defined in our previous video. We have a divider function which takes in 2 arguments, and we return x divided by y. Now when building this function, we have to think about how information will be passed into these parameters. Is it user input? Is it hard-coded? How are numbers going to be passed in? And depending on how they're going to be passed in, do we need to tackle the scenario where y, for example, could be a string or a 0, which would then cause us to run into an error which we saw in the previous video. Now the try statement is used to catch the exception, and what we place inside the try block is the statement that could raise an exception. So for example, we'll first put the keyword try with a colon. Now inside the try block, we can now include the statement that could potentially raise an exception. And we know this is a call on the divider function. So we'll put divider, and inside parentheses, we'll start by putting the integer 10, and then we will put the string 2. So before we've even run this, we know there's going to be a type error exception that would occur from this scenario. And we will store the result of this function in a variable called result. Now after the try statement, we can then include an except statement. And the except statement is essentially the statement that will handle the exception if one is observed within the try statement. So we can put except and then a colon. Now for simplicity, we will simply just print a message saying, are you sure you're inputting 2 numbers? So what this will do when we run this statement, will first of all try storing the divider function's result in a variable called result. Now if there is an exception that's raised, irrespective of the exception, you can see we have an except statement which simply prints, are you sure you're inputting 2 numbers? So if I run this code, you can see that we print to the screen, are you sure you're inputting 2 numbers? And we don't observe the type error on screen, which is great. It means our exception has been handled and our program hasn't crashed. In addition to the try and except statements, we can also include an else statement. And what the else statement will contain is code that executes when no exception occurs. So we've tried calling the divider function, and in this example you can see that our exception is handled via this except code block, but if we put an else statement, we know that no exception would have occurred, and we can print something to the screen like, everything run smoothly. And then we can print what's stored in the result variable. So if I run this code, you can see that we're presented with the message, are you sure you're inputting 2 numbers? And that's because an exception has been raised. But if I change the string 2 to the number 2, you can now see that we print to the screen, everything run smoothly, and then we get 5 as the result. So we try some code. If there's an exception that's raised, we will then put some code in the except statement that handles that exception. If no exception occurs, then the code in the else statement will be run. Now there is one final statement that we can also include in addition to try, except and else, which is known as finally. And a finally block will always get executed whether there is an exception that's generated or not. So for example, if after the else statement I put finally with a colon and then print I always run, you can see that we don't run into an exception because our else statement has been executed, so we print everything runs smoothly, we get the result of 5, and then we print I always run because the finally block is always executed whether there's an exception or not. If I change the integer 2 to be a string representation, you can see that we print to the screen, are you sure you're inputting two numbers? Because it's caught by the except block, because an exception has occurred. But then we also then print, I always run, because once again, the finally statement is always run. So hopefully you're starting to see how you can try some code, observe whether there's an exception, write some code that then handles that exception. You can have an else block which is executed when no exception occurs, and then you can also have a finally statement. It's not compulsory, but you can if you see fit. Now currently, the except statement that we've included is going to be run irrespective of the exception that's observed. So for example, if I change the string 2 here to be the number 0, you can see that we print to the screen, are you sure you're inputting two numbers? Well yes, we're dividing 10 by 0, but we know we can't divide by a 0 because a 0 division error would occur. So what we can do is we can be more specific with our except statement. So just above this except statement, I will also create another except statement, but this time I'm going to stipulate the error that I'd like to be handled. So I can put except and then put 0 division error, then a colon, and then I can write code that will be executed if a 0 division error is observed. So for this purpose I'll simply print, you can't divide by a 0. If I now run this same code, you can see that we now print, you can't divide by a 0, and then we print, I always run, based on that finally statement at the end. And once again, if I change the 0 to be the string 2, you can see that we now print, are you sure you're inputting two numbers? And this is because the error would be a type error, so therefore it's not caught by the except 0 division error, and all other errors are captured by the except block. So this is a way of being able to handle different errors in a different way. So let's now think of a practical example as to how we can use the try, except, else, and finally in a specific program. So we'll first of all define a function called enter a number, and we'll put parentheses with a colon. Inside of this function, we'll then create a while loop, so we'll put while true, and we know because true is always true, we have to at some point break out of this while loop by using the break keyword. So we'll first of all ask for input from a user, and we'll put input function and then the message enter a number. We will then convert this to an integer by wrapping this in the built-in int function, and we'll then finally store this in a variable called num. Now my first thought here is that a user may be asked for a number, but they put in a letter accidentally, and this will therefore mean they run into a value error. So I want to wrap this in a try block in order to see if there is an exception that's raised based on their input. I can then put an except block, which will then be code that is executed if there is an exception that is raised. So I'll print that is not a number, try again. And what I can then do is place the continue keyword, which will take us back up to the top of the while loop, and then request their input again. We can then finally have an else block, which we know would be executed if their input is indeed a number, and it can be converted into an integer. So I will then print good choice, and at this point I'm happy to break out of the while loop, so I can then put the keyword break. I then simply want to return the number that they've provided, so I can then use this number in other parts of my code. So if I run this code cell and then call upon the enter a number function, you can see that we're asked to enter a number. So let's suppose I put the number 2 as the word 2. You can see that when I try to run this code, we're presented with the message, that is not a number, try again. And that's because when we've tried to input a number, we would have run into a conversion error when trying to convert the word 2 into an integer, so we would have got a value error. We've therefore printed the print statement that is not a number, which is written within the except block. If I try to put the number 10 as a word, you can see we get that is not a number, try again. But if we put an actual number, let's say we put 20, you can see that we get returned good choice, and we've returned 20 from this function call. So it's a much more controlled way of being able to implement some code and foreseeing the potential issues that could arise based on inputs from users. So without risking our program completely crashing on us because a user passes in some incorrect information, we're able to utilize the try, except, and else statement in order to add an increased level of control to our code. Now when you test your programs, a good thing to try to do is to break them. If you end up breaking them and you run into exceptions, you need to then somehow handle these exceptions so that when the program goes live and a bigger community starts using it, they don't run into the same issues. In the next video, we're going to see how users can define their own exceptions.